In this video, I'll show you how to graphically solve inequalities. Question 1 reads, graphically solve the linear inequality 3x minus 4 is greater than x plus 2. To do this question, I'll graph 3x minus 4 and graph x plus 2 using two different colors. Starting with 3x minus 4, our y-intercept here is negative 4. So we'll place a point right here, and this is at 0 and negative 4. And our slope, which is right here, 3, is the stepwise pattern that we use from this point. And given that this 3 is positive, we'll go up 3 and over 1, because 3 is the same thing as 3 over 1, and this is our rise and this is our run. Another 3 up, 1 over, another 3 up, over, and so on. Next, we will plot x plus 2. X plus 2 has a y-intercept of 2, which means that it starts over here, and a slope of 1. In other words, 1 over 1, rise over run. 1 up, over 1, 1 up, over 1, 1 up, over 1, and so on. The next thing I'll do is connect these dots. And now what we have to do is interpret when this line will be greater than x plus 2. Remember, this line right here represents x plus 2, and this line represents 3x minus 4. 3x minus 4 is clearly greater after this point. And that point has the coordinates 1, 2, 3. 3 as the x, 1, 2, 3, 4, 5, and 5 as the y coordinate. So anything after 3 and 5, this line is greater than this line. And the way we can represent this mathematically is x must be greater than 3. In question 2, we're asked to solve the nonlinear inequality x squared minus 3 must be greater than 2x. To solve this inequality, we'll first need to rearrange the terms, where I'll bring this 2x over and I end up with x squared minus 2x minus 3. And that needs to be greater than 0. And I'll graph x squared minus 2x minus 3 by first finding the critical points. In other words, I'll factor the left side and find out what my x-intercepts are. What two numbers multiply to negative 3 and add to negative 2? The numbers that I'm thinking of are negative 3 and positive 1. Negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. So I'll break the left side into two parentheses, and I'll put minus 3 here, and I'll put plus 1 here, and this side needs to be greater than 0. If I solve for x for this bracket, I end up with x must be greater than positive 3. And if I solve for x here, I have x plus 1 must be greater than 0. Now solving for x, I end up with x must be greater than negative 1. The point that represents this critical point is 3 and 0. And the point that represents this critical point is negative 1 and 0. Let's plot those. We have 3 and 0, which is over here, and negative 1 and 0, which is over here. Since it's a parabola that opens up, notice that this x squared is positive, we can assume that it goes like this. And I don't know exactly where the vertex is. It doesn't matter at this point. But we know that the left side, look, it has to be greater than 0. And when is y greater than 0? It's greater than 0 going this way and going this way. This y-axis is greater than 0 after this point and after this point. Therefore, we can conclude that x must be less than negative 1 and x must be greater than 3. And there you have it. Two examples on how to graphically solve inequalities.